All right, thank you. So for the last talk, I'm going to try and take you into space. So if you live in a place like where I do, up in the Peak District, on a clear sky, if you look up in space, most of the time, what do you see? You see the permanent celestial bodies like stars and planet, right? Then between yourself or me, who is looking up, and these permanent bodies, over the last few decades and centuries, we have started filling this vast space now, right? Since the 60s, 50s and 60s, first we sent in satellites during moon exploration. Then we started putting in military hardware for military use. More recently, what's happening is this is just a start. In the next few decades, what's going to happen is we're going to go from having few hundred satellites and other objects into this vast space. We're going to have hundreds of thousands and even millions of these things up there. So the question we should ask ourselves is a couple of things. One, how are these things powered? Right? There are two things to consider there. One, how do we get these things where we build them on Earth? How do we take them into space? Then how do we keep them in the orbit? These are two separate things. Taking things from the Earth into space, we use traditional technology, burn a lot of fuel. We have all seen the image of this mushroom cloud that the rocket leaves behind, right? That's just jet fuel. Now, once you get into space, you don't have oxygen. You can't really use the traditional fuel, hydrocarbon, fossil fuel. So there we end up using something even more toxic. You don't need to know the name. It's called hydrogen. That's the traditional fuel. That doesn't need really oxygen to generate power. Now, the question may be that the space is so vast. Why do we need to worry about putting toxin in there? Our history as human species is not great in this area, right? We thought rivers were vast. We can put anything we want down the river. It will be washed away. Ocean is even bigger. It will end up there, dilute, and it won't be our problem. Now, see where we have ended up with that idea. Exact same thing is going to happen in space if we are not careful. So what's the solution? We already have the solution. The solution is you start with a bottle of water. Doesn't have to be a bottle. You start with water. Then using sunlight, there is copious, large amount of sunlight anywhere in space, right? For the most part. Take the solar energy, use the solar energy to split that water into hydrogen and oxygen. That hydrogen you produce is your fuel, right? Now, you can store both hydrogen and oxygen in separate tanks. When you need power, now you recombine them, right? And when you recombine them, you release the energy. And that energy keeps their satellites into orbit. This is not a new technology. Actually, this was already being done when the American Space Agency and Soviet space agencies first went into space, because they were carrying human beings, astronauts. Astronauts needed water, oxygen. We didn't care about hydrogen back then. Nobody thought about hydrogen as the fuel. We are splitting water, making oxygen so that the astronauts could breathe oxygen in. Now, and the hydrogen was just being vented out. Same thing was happening in submarines. Underwater, you needed oxygen. There were a device called electrolyzer that was splitting water to generate hydrogen, then generate oxygen. Hydrogen was just getting vented out. Now we want to take that hydrogen because it's a fuel and use it. The beautiful thing about all of this is when you use hydrogen as a fuel, you are actually combining with oxygen that you generated, and the end product is just water. So we start with water, end up with water, there is no waste. Now the question becomes, why aren't we already doing this? The simple answer is in order for something to work in a large scale, somebody has to make money. This technology is expensive. A private entity is very reluctant to invest in this type of technology until now, because this same concept I just described to you is being used. It's the exact same technology we are using on Earth to transition from fossil fuel to renewable energy. We have the technology. We have enough renewable energy to do everything we are doing right now all around the world. The problem is renewables like solar and wind, they are something called intermittent. Sun doesn't always shine, wind doesn't always blow. So you have to generate energy, capture energy. You have to have a way to store it. That storage technology, it's down the line in our lifetime. We're going to do everything that we do with fossil fuel with something like hydrogen. It doesn't have to be hydrogen, right? So when you take vast amounts of renewable energy, use that energy, first convert it into electricity, use that electricity to split water into hydrogen and oxygen. Then we're going to transport that hydrogen just like we transport petroleum, natural gas all around the world. We're going to do the exact same thing with hydrogen. Then you can burn that hydrogen or use hydrogen in a different way to release the energy. So there is a solution. What's my interest in it? Besides having a job, because I'm a scientist who can do research and somebody pays me money, is because where I grew up, in a remote village in the Himalayas in far western Nepal, I had not even seen a bicycle until I was a teenager. The skies were clear, our water sources were clear, right? But because of the effect of industrialization, our water sources are drying up because the glaciers, we depend on our water. The glaciers, we depend for our water. They're melting away faster than... It's a common knowledge now, right? I don't really need to convince a crowd, especially an educated crowd. So there is personal interest for me. If you still feel you are detached from this problem, it's going to come back and hurt you as well. So how do we convince our policymakers? So one of the questions I always get asked, especially if I talk to children, is, are we going to get to net zero? Probably not children, teenagers, right? That's the simple, basic question. That's the difficult question as well. My answer is, technologically, we already have the solutions. We will find technological solutions. Where we're going to get stuck, where we already are stuck, is at the policy level. So what each of you can do is convince the policymakers. Thank you.